Hi everyone, this is Christian
And I am Joel.
and we are your teacher for today. So hi everyone, so since we are already on the third quarter or third part of our whole year, so now we are already on our lesson 4, which is the elements and compounds. So before we start our discussion, did you remember that I gave you an assignment last time to research, to study more about elements and compounds? And now, since I given you that assignment, so now let's test what is your prior knowledge before we discuss the elements and compounds. Okay, so let me ask you, is there anybody in the class that can tell the difference between the elements and compounds? Okay, thank you for that. So now, let me ask someone in the class, how are the elements related to compounds? That's right. So now, let me ask someone, what changes must happen to an element to become a compound? Okay, so thank you for that. So now, let me ask someone, can the elements be broken down? Thank you for that answers. So thank you for your cooperation and participation in this class. So now, let me tell you all the goals and objectives. After this discussion, you are able to first define what is elements and what is compound. Second is you can list down some examples of elements and compounds. Third is you are able to identify what are the characteristics of an element and compound. And fourth, you are able to identify a substance, either it is an element or a compound. And last, you are able to write and identify the chemical symbols for an element and compounds. So let's reserve those questions later after this activity. So those questions will be answered by this activity. So our activity will be the short video watching. So we will be watching a short video clip that will enable you to understand what is element and compounds. So while watching the video clip, I will be giving you a task. So you need to make a table, one table with 3 columns. So on the first column, you need to write the top of that substance. So you need to write all the substances that is mentioned by the teacher on the video clip. And then on the second column, you need to identify the substance if that is an element or compound. And on the last column, you need to write the chemical symbol of the substance. So if, for example, we have the teacher mentioned about salt. So salt is a compound, and the chemical symbol of the salt, since salt has 1 sodium atom and 2 chlorine atoms, so that should be sodium chloride. So you need to write its chemical symbols of a compound. Okay, so since everyone here already know what to do while watching the video clip, so let me now play the video. Okay, so since we are all done with the activity and with the video clip watching, so now let me again ask you, class, what is the difference between elements and compounds? How are the elements related to compounds? And what changes must happen to an element to become a compound? And last, can the element be broken down? Okay, so thank you for those answers. So it seems like you already understand the basic concept of the elements and compounds. So let us bring you more into the complexity of discussion, which is the elements and compounds. Okay, so now let's start the discussion.
Okay class, let me give you a clear understanding of our topic, which is the elements and compounds. First, elements are the simplest complete chemical substances. Each element corresponds to a single entry on the periodic table. An element is a material that consists of a single type of atom. Each atom contains the same number of protons. Like for example, the hydrogen having a protons of 1, and another example is oxygen having a protons of 8. Each atom has an atomic number, which represents the number of protons that are in the nucleus of a single atom of that element. The periodic table of elements is ordered by ascending atomic number. Like for example here, hydrogen have only 1 atom, while the last element, which is the oganesson, have 118 protons. The chemical elements are divided into the metals, the metalloids, and the non-metals. Metals typically found on the left side of the periodic table. These are often conductive to electricity, malleable, shiny, sometimes magnetic. Like for example, the aluminum, iron, copper, gold, mercury, lead are metals. The examples of non-metal elements are carbon and oxygen. Metalloids have some characteristics of metals and some characteristics of non-metals. Like for example, the silicon and arsenic are metalloids. As of November 2011, 118 elements have been identified, or the most recently identified was unseptium in 2010. Of these 118 known elements, only first 98 are known to naturally on Earth. The elements that do not occur naturally on Earth are the synthetic products of man-made nuclear reactions. 80 of the 98 naturally occurring elements are stable. The rest are radioactive, which means that they decay into lighter elements over time scales ranging from fractions of a second to billions of years. Hydrogen and helium are by far the most abundant elements in the universe. However, iron is the most abundant element, or by mass, in the composition of the Earth, and oxygen is the most common element in the layer that is the Earth's crust. Although all known chemical matter is composed of these elements, chemical matter itself constitutes only about 15% of the matter in the universe. The remainder is dark matter, a mysterious substance that is not composed of chemical elements. Dark matter lacks protons, neutrons, or electrons. So next is the compounds. Pure samples of isolated elements are uncommon in nature, while the 98 naturally occurring elements have all been identified in mineral samples from the Earth's crust. Only a small minority of them can be found as recognizable, relatively pure minerals. Among the more common of such native elements are copper, silver, gold, and sulfur. Carbon is also commonly found in the form of gold, graphite, and diamonds. The noble gases, like for example the neon, and the noble metals like mercury can also be found in their pure, non-bonded forms in nature. Still, most of these elements are found in mixtures. When two distinct elements are chemically combined, chemical bonds form between their atoms. The result is called a chemical compound. Most elements on Earth bond with other elements to form chemical compounds such as sodium and chloride, which is the salt.
Okay, so water is an example of compounds. So as discussed earlier, that the elements in a compound can be separated through what we call chemical reaction. So the chemical symbol for water is H2O. Two atoms of hydrogen and one atom of oxygen. So let's draw the chemical illustration of the water. So one molecule of oxygen and two molecules of hydrogen. So these two atoms of hydrogen and one atom of oxygen is connected or combined through what we call chemical change. So the two atoms of hydrogen and one atom of oxygen form what we call the H2O compound or the water. Okay, so that is the combination of those elements. So in the combination, in the process of what we call chemical change, the elements form a compound which is water. So now, if the water undergoes the what we call chemical reaction, like for example, there is a water on the pan, and then we applied heat or fire. So the tendency of the water, if the water reaches the 100 degrees Celsius, because that is the boiling point for the water, so the water will boil and the evaporation will take place. So meaning the elements on this water, which is the hydrogen and oxygen, will evaporate and will separate to each other.
Chemical compounds have a unique and defined structure, which consists of a fixed ratio of atoms held together in a defined spatial arrangement by chemical bonds. Molecular compounds held together by covalent bonds. Salt held together by ionic bonds. Intermetallic compounds held together by metallic bonds. Complexes held together by coordinate covalent bonds. Pure chemical elements are not considered chemical compounds, even if they consist of diatomic or polyatomic molecules, or molecules that contain only multiple atoms of a single element, such as hydrogen having a 2 atom, or sulfur having a 8 atom. If you pull a flower petal from a plant and break it in half, and then take that piece and break it in half again, and take the next piece and break it in half, and so on until you cannot even see the flower anymore. What do you think you will find? We know that the flower petal is made up of cells, but what are cells made of? Scientists have broken down matter, or anything that takes up space and has mass, like a cell, into the smallest pieces that cannot be broken down anymore. Every physical object, including rocks, animals, flowers, and your body, are all made up of matter. Matter is made up of a mixture of things called elements. Elements are substances that cannot be broken down into simpler substances. There are more than 100 known elements, and 92 occur naturally around us. The others have been made only in the laboratory. Inside of elements, you will find identical atoms. An atom is the simplest and smallest particle of matter that still has a chemical properties of the element. Atoms are the building block of all the elements that make up the matter in your body or any other living or non-living thing. Atoms are also small that only the most powerful microscopes can see. atoms themselves are composed of even smaller particles, including positively charged protons, uncharged neutrons, and negatively charged electrons. Protons and neutrons are located in the center of the atom, or the nucleus, and the electrons move around the nucleus. How many protons an atom has determines what element it is. For example, a hydrogen has just one proton, and helium always has two protons, while sodium always has 11 protons. All the atoms of a particular element have the exact same number of protons. All the number of protons is that elements having a atomic number. An atom usually has the same number of protons and electrons, but sometimes an atom may gain or lose an electron, give the atom a positive or negative charge. These atoms are known as ions, are depicted with a positive symbol or a sign. Ions such as hydrogen plus and sodium plus and potassium plus or chlorine negative have significant biological roles. An atom of helium contains two positively charged protons, two uncharged neutrons, and two negatively charged electrons. The periodic table of elements. In 1969, a Russian scientist named Dmitry Mendeleev created the periodic table, which is a way of organizing elements according to their unique characteristics, like atomic number, density, boiling point, and other values. Each element is represented by a 1 or 2 letter symbol. For example, H stands for hydrogen and AU stands for gold. The vertical columns in the periodic table are known as groups, and the elements in groups tend to have very similar properties. The table is also divided into two rows known as periods. The periodic table groups the elements based on their properties. The table begins with hydrogen, atomic number of 1. An element is a substance that cannot be chemically decomposed into simpler substances. An atom is the smallest particle of an element that can take part in chemical reactions. A compound is a substance formed from two or more elements chemically joined or bonded together. A compound has a definite chemical composition and hence specific formula. A compound has a chemical properties different from properties of the element it contains. Molecules are substances formed when two or more atoms are chemically joined or bonded, while elements are the simplest complete chemical substances. Each element corresponds a single entry on the periodic table. An element is a material that consists of a single type of atom. Each atom type contains the same number of protons. Elements cannot be divided into smaller units without a large amount of energy. Compounds, on the other hand, can have their bonds broken with practical amounts of energy, such as the heat from a fire. A chemical element has a pure substance that consists of one type of atom. Each atom has an atomic number which represents the number of protons that are in the nucleus of a single atom of that element. The periodic table of elements ordered by ascending atomic number. So now I will discuss with you about the chemical reaction. A molecule is any combination of two or more atoms. The oxygen in the air we breathe is two oxygen atoms connected by a chemical bond to form two atoms of oxygen, or molecular oxygen. A carbon dioxide molecule is a combination of one carbon atom and two oxygen atoms, or CO2, because carbon dioxide includes two different elements. It is compound as well as a molecule. While a compound is any combination of two or more different elements. A compound has different properties from the elements that it contains. Elements and combination of elements or compounds make up all the many types of matter in the universe. A chemical reaction is a process that breaks or forms the bonds between atoms of molecules and compounds. For example, two hydrogens and one oxygen bind together to form water, or H2O. The molecules that comes together to start a chemical reaction are the reactants. So hydrogen and oxygen are the reactants. The product is the end result of a reaction. In this example, water is the product. Atoms also come together to form compounds much larger than water. It is some of these large compounds that come together to form the basis of the cell. So essentially, your cells are made up of compounds, which are made out of atoms. Pure samples of isolated elements are uncommon in nature, while the 98 naturally occurring elements have all been identified in mineral samples from the Earth's crust. Only a small minority of them can be found as recognizable relatively pure minerals. Among the more common of such native elements are copper, silver, gold, and sulfur. Carbon is also commonly found in the form of coal, graphite, and diamonds. The noble gases like neon and noble metals like mercury can also be found in their pure or non-bonded forms in nature. Still, most of these elements are found in mixtures. To make a compound, there must be a chemical reaction where bonds are formed and entirely new substance is created. Without that chemical reaction, a chemical substance means form a mixture. The components of mixture keep their original properties and can easily be separated. Elements cannot be broken down into a simpler substance. Likewise, one element cannot be chemically converted into different element. Chemical elements are the simplest substances. Most elements do not exist as such in nature.
Okay, so that is all about the elements and compounds. So we already know all about the elements, the compounds, how they form, and what are natural and not unnatural. So since we already have an idea about elements and compounds, and we already understand what is that all about. So what are you going to do is you will be creating a 5 minutes vlog showing and identifying the different elements and compounds at home and its uses. So at home, you will be creating a 5 minutes vlog, and then you will be identifying your basic needs, like for example salt. So you need to identify if that is a compound or element, and you need to also give what is the use of that material. Okay, so that activity will be submitted. I will be giving you 1 week preparation for that task or for that activity. So now you can already start doing your black, editing, and finalizing it. So now the other activity that you can also submit at the end of the semester or the end of the grading or quarter of the end of this quarter is you will be conducting an interview on your barangay with at least 20 respondents. So you need to ask the following questions. First, you need to ask them what are the 5 usual materials that they are using in their daily lives. And then you need to ask them what are the uses of those materials in their daily lives. Okay, so in doing this activity, the interview, so in gathering all those information, you need to create a table. So I will be sending the sample table on our group chat. So you have there 3 columns. The first column is for the respondent's name. The second column is the first question. What are the 5 materials that they are using usually in their daily lives? And then the third column, the last column, is the uses of those materials. Okay, so your assignments for this lesson. So tomorrow, I will be giving you a day to prepare or for the presentation or for the recording. So I will be assigning 5 groups for this class in order for you to collaborate and to share or to brainstorm your ideas about the knowledge and learnings on the discussion that we have earlier. So you will be creating a PowerPoint presentation with just few slides that you need that will showcase or that will show your understanding about the topic. So yeah, and for the presentation and or reporting for tomorrow, please be guided with this criteria for rating. So the content of your reporting for or presentation for tomorrow is 50%. The reporting is 20%. So the loudness of voice, the clarity, all of that is here on the reporting, 20%. So we also have teamwork or cooperation, that is 10%. So you need to take note all the contributions of your members or the task given. And then we have here 20% for your creativity. So you need to make your presentation interactive and beautiful. So that's our activity for tomorrow. Okay, since we still have time, I will be asking everyone to get one whole sheet of paper. So write your name first, your grading section, and then the date today. So you need to create a table with 3 columns. On the first column, you need to write 10 examples of elements and 10 examples of compounds. On the second column, you need to identify if that is an element or compounds. And on the last column, you need to draw or to show the molecular form of that element or that substance, like the element or the compounds. And that ends our discussion for